This is the largest plane in the world.
The Antonov is unmatched as far as how extraordinary of a flying machine it is.
I thought, how is that possible? A wing as long as a football field? No way this thing can fly.
The Antonov AN-225 is unique. It's set over 200 world records and has a huge global following.
It's sort of a spectator sport when people come out to watch the Antonov take off and land.
This aircraft is huge. It even dwarfs a Boeing 747.
With a maximum takeoff weight of close to 800 tons, it's so incredibly heavy, it appears to defy science. So what extraordinary feats of engineering enable it to fly? The only way to find out is to look inside it. The giant Antonov AN-225 is a cargo plane like no other. Its role? Transporting the heaviest air freight on Earth. In May 2016, it undertook an epic journey, transporting a huge industrial generator from Prague to Perth, Australia. Public interest was so high that a German news crew filmed it every step of the way. Dmytro Antonov is in charge. He's not related to the company founders, but he is one of a select group of pilots qualified to captain the plane.
We are carrying some very heavy cargo. For example, to Australia we are bringing a generator. We have so big cargo and now we'll fly with this cargo. How is possible? But I know it's possible.
This
Antonov is the only plane that can load over 100 tons. The generator weighs 117 tons.
That's the weight of 18 African elephants. And transporting it by air is super expensive. Hiring an AN-225 costs about $30,000 an hour. For that, you get the largest plane in the world. If you were to park it in a soccer stadium, its 290-foot wingspan would reach over both touch lines. And its 275-foot fuselage would stretch from box to box.
It's unique. Only one in the world, and the still biggest plane in the world.
The first challenge is how to get the generator into the fuselage. Remarkably, the front of the plane is hinged.
The Antonov AN-225 is so cool. Because the nose lifts up, it gives you quite open access to the entire cargo bay, so you can easily load things in.
Precision hydraulics lift the normally sealed nose and open the fuselage like a giant mouth. But it's too far off the ground to load into directly.
It kind of bows down in order to swallow the cargo. It's almost like a big snake that like unlatches its jaw and then comes down to the ground to like eat its prey.
The leading undercarriage pylons are jointed. And as the fuselage lowers, a ramp unfolds, allowing an 11-strong team to crane the generator into position. The AN-225 has a maximum takeoff weight of 800 tons. With cargo and fuel on board, it's not far off that now, and will be heading down the runway in less than an hour. The 225 wasn't originally a commercial plane. It was designed in the 1980s at the height of the Cold War. The Soviet Union's military had begun a clandestine program to develop a space shuttle to rival America's, and they needed an enormous place to transport it.
At the time, it was not public at all. It was all top secret. No one knew about it.
The Soviet shuttle, known as the Buran, was far too big to fit inside any existing fuselage. So the USSR invited Ukraine's finest designers and engineers to take up the challenge.
We were all so excited. We had sparkles in our eyes, filled with the desire to put in as much of our knowledge and abilities as possible to find the best solution for this aircraft.
They knew they had to design a plane the likes of which had never been seen before.
I can only say that obviously the most complicated part was to design this wing.
The wings needed to be vast, but where they're positioned is also critical. Civilian planes have wings mounted as low as possible.
They're attached to the bottom of the aeroplane, and you'll see that the wings are slope upwards from what we call the wing root. And the reason for this is dynamic stability and control of the aircraft. And we call that upsloping wing dihedral.
This means that if, for example, a gust of wind pushes the aircraft and it rolls in one way, the aircraft naturally wants to stabilize itself.
In the case of the AN-225, another similar military cargo type aircraft, the designers use an anhedral wing shape, which is the wings sloping down from the center of the airplane out to the wingtips.
The reason is that carrying heavy loads negates the need for the extra stability that an upwards dihedral angle would give.
But also the wings look more anhedral than they're going to be in practice when the plane is flying, because the wings are flexible. And when the wings get loaded by generating lift, they actually will rise up a little bit. So the anhedral angle is to kind of balance out the natural deflection you get of the wings under lift, so it kind of evens out to about level.
When the AN-225 took its maiden flight in 1988, it was a tense moment.
This is so much bigger than anything that had flown and was flying at the time. The engineers who'd created it must have had some trepidation about whether or not their creation was actually going to get airborne.
It's very difficult to express your feelings. You know, this feeling if your heart stops and knots build up in your stomach. But I can tell you, the delight from seeing how the aircraft smoothly, beautifully, slowly, literally, graciously takes off.
The AN-225 soared into the sky triumphantly and took even its engineers by surprise.
I thought, how is that possible? A wing as long as a football field? No way this thing can fly.
The plane went on to prove it could also fly with the shuttle on board and was nicknamed Maria, Ukrainian for dream.
The plane was unveiled to the public in the Paris Air Show 1989, and it really stole the show.
I remember looking around and seeing that the queues of people to see Maria was larger than the rest of the audience combined together.
I was walking around all puffed up with pride, and I let everyone I met know that I'm a test pilot.
For Ukraine, it was a historic moment. Like never before, the then Soviet country led the world.
I always talk about our constructors with such pride. Those people are outstanding. They're the gold of our nation.
But the halcyon days were short-lived. When the Cold War suddenly came to an end and the Soviet Union collapsed, it was curtains for the Soviet space program, too.
Sadly, the AN-225 became surplus to requirements and was mothballed. There was a distinct possibility that this amazing machine, of which there was only one, was going to be allowed to rot, become dismantled, fall apart, and never take to the air again.
After being left to rot for years, the largest plane in the world comes out of retirement. In 2001, the Antonov company spots a gap in the market. About $20 million is spent on a refit, and the AN-225 becomes the most spectacular civilian cargo plane.
The floor is strengthened for transportation of heavy cargoes. We have lightened devices like chains, which are nowhere near as heavy as in previous aircraft. The locks are screwed down into these holes, and we fix the cargo so that during the flight it doesn't move anywhere and is safely fixed inside the aircraft. With the help of the winch, we can drag any cargo inside here. The winch can be positioned anywhere on the floor.
The cargo hold is enormous, 20 feet wide and 141 feet long. That's longer than the distance the Wright brothers flew on their famous first powered flight. And just enough room for the AN-225 to set the world record for the longest cargo ever carried by air.
We are sometimes getting very interesting one piece of blade wind turbine. It's 10 tons, but it's very long. No other can do it. They can do it by sea, but it's long time. It's maybe 1 month to carry this blade.
Every loading is a challenge, I would say. This plane is not ordinary, and its cargo are not ordinary, so it's always tricky to load it.
The conversion is a triumph, enabling the plane to swallow up all kinds of giant cargo, and even the heaviest air freight ever.
All crew feeling very proud, all persons proud to be a part of the team of this plane.
In September 2001, the AN-225 carried not one, but 5 battle tanks, serious heavy lifting, and a world record load of over 300 tons. Somehow, they all fitted into the fuselage.
I remember, I was there, helping to drag in, adjust and secure the tanks.
Their total weight was around 250 tons. Actually, I think they weighed a bit more. And we lifted this weight to an altitude of 10,250 meters.
These record loads are far heavier than the 128-ton space shuttle.
In its new role, the structural stresses on the aircraft would be really significant.
Luckily, the 225's original designers had cleverly over-engineered the wings.
It's hard to believe that something that large and that heavy can ever lift up into the sky on its own.
The designers knew that their plane should generate more lift than any other in existence. It was completely uncharted territory.
There are 2 ways you can get a wing to generate more lift. One is you make it move through the air faster, or you make it bigger. they realized that they would have to have wings that were bigger than anything that had gone before.
The broader a wing is, that is, the more area it covers, the more total upward lift you can get. The Antonov's wings are actually wider than the length of the plane. Every piece of that wing is now adding to the lift that it can supply to lift the whole plane off the ground.
Enormous wings, though, add even more weight and create a potentially disastrous weakness.
As you make a longer and longer wing and that is experiencing lift, you're putting more and more load on the wing.
The largest loads in any wing are typically around about the wing root, so where the wing joins in with the main fuselage of the aircraft.
Dmytro gets the go-ahead to begin his 4-day mission to fly this huge generator to Australia. The AN-225 thunders away from Prague.
I'm flying about 14 years. Flying in the biggest plane in the world, it's an amazing feeling.
With his super heavy cargo and wings this long, it's a mystery the wings don't shear off at the stress points where they join the fuselage. The answer is hidden inside the wings. Underneath the aluminum skin is a regular arrangement of ribs, but in the central section, there are 4 large reinforcement beams. These prevent the colossal lift force acting on the joints by fixing the wings together and spreading the load. Inside the Antonov hangar in Kiev, Ukraine, a second AN-225 lies half-built, with the inner structure of its wings exposed.
You can see how one of the beams of the fuselage reaches the center section and is attached to the girders of the wing. You can see the attachment. This is what guarantees safety from the load the wings put on the fuselage.
After flying roughly a third of the journey to Perth, Australia, Dmytro brings the AN-225 and its huge generator cargo down to fill up in Turkmenistan, where jet fuel is known to be cheap.
Well, the AN-225 is burning 15 tons of fuel per hour, so fuel cost is quite significant.
This plane burning every hour more fuel than, for example, Boeing 737 have for whole trip.
Refueled and back in the air, the next stop will be Hyderabad, India. But a hydraulics problem is about to threaten the mission.
Getting spares for a true one-off aircraft such as AN-225, whether you're in Hyderabad or wherever in the world, is always going to be a challenge.
The largest plane in the skies, the unique AN-225, is en route to Perth, Australia, where it's due to deliver this massive 144-ton generator in just 3 days' time. Next fuel stop, Hyderabad, India. The news crew filming the journey capture a crowd of fans flooding the runway to witness the event.
It's an honor to have it over here and coming in the South Asia Pacific region for the first time. So it's really a matter of pride for us.
Dmytro is fast becoming an international celebrity.
I remember one more time in Honolulu when I first came to Hawaii. It's approximately the same. I have flowers, and but without the stick on head.
The crew suddenly discover all is not well beneath the wings. There's a problem with the hydraulics, a major concern for flight manager Vitaly Shost.
Not broken. As I said, it doesn't work properly in this case, but it's not broken.
Flight plans are hastily rearranged and the crew rush to make repairs. If they're unsuccessful, the delivery will be abandoned.
We are trying to solve this issue.
The crew are forced to disembark, and burning through a $30,000 per hour rental fee, the client is getting anxious.
It makes my job more difficult, you know, because I need to drop my things, my retired things, and pay attention to all of them. But still, nobody rejected me to do my official duties.
Hydraulics play a vital role in the AN-225. One of their functions is at the heart of how the plane maneuvers in the air. On small planes, control surfaces, like the ailerons on wings, are physically linked to the cockpit. Levers mechanically transmit the pilot's commands to the control surfaces. But on the AN-225, that would be impossible because those control surfaces are so large.
If you imagine the forces involved in opening a door into a hurricane force wind, you get an idea of the kind of forces you're going to need to push on these surfaces.
The solution is known as a fly-by-wire system. The genius of this is it eradicates the need for the pilot to have any mechanical links to the flaps.
A fly-by-wire system enables you to have the cockpit and have the controls at the cockpit connected electronically back to the actuators that turn the control surfaces.
Behind the cockpit is an array of computers. When the pilot operates the controls, the instructions are processed electronically and then sent down hydraulic lines. These fluid-filled pipes are connected to powerful hydraulic pistons called actuators, which deliver the force needed to move the huge control surfaces.
The hydraulic system takes advantage of Pascal's principle, where the pilot can put in a relatively small force but pushed over a large distance, and through the hydraulic system that gets translated to a large force but over a smaller distance, a little bit like the way a lever works.
Hydraulics also play a crucial role inside the plane's unusual tail configuration, a consequence of being designed to carry the Soviet space shuttle.
The Buran is attached to the 225 here on these humps.
Carrying the Buran outside the fuselage threw up a significant aerodynamics problem.
Well, trying to fly a plane with something as enormous as a Buran space shuttle on top of the fuselage is, of course, very challenging. And one of the major challenges is the fact that it disrupts the airflow that would take place as you move down the plane. And that's normally where the vertical and horizontal stabilizers would be.
When a model plane was tested in a wind tunnel with the Buran on top, there was too much buffeting on the tail.
So if you arrange the space shuttle right in front of the vertical stabilizer, the rudder of the plane, the rudder may not be as effective.
The turbulence would make the plane virtually impossible to maneuver. For the Ukrainian designers, a single tail fin had to be rejected.
So what they did is they actually used two rudders outset from the fuselage in order to get outside of that disrupted airflow, so it could still fly effectively even with a space shuttle on its back.
Now the trail line from the Buran will pass between them without causing buffeting.
The twin tail solves one problem, but it creates another.
Now you've got to have two separate rudder systems which have got to work in a coordinated sense and move together in order to control the aircraft correctly.
Engineers avoided a major design fault by installing two sets of powerful hydraulic actuators that are linked together electronically. Sensors monitor their relative positions, guaranteeing that the actuators move both rudders or both elevators in unison.
In flight, I believe it's like other else aircraft. Flying, it's very light control, it's good.
But that's only when the hydraulics are working properly. If they're not, the pilot risks losing control.
We took off once and were passing Europe when we lost hydraulic liquid from the second system. We carried on flying. When liquid left the second system, it started leaking from the third system. That became dangerous.
Often, planes have three parallel hydraulic systems, so that if one leaks, others can take over and maintain control.
So I made a decision to land at the closest airport. When we landed, we were down to the last few liters of liquid.
This remarkable escape was down to the Antonov's extra redundancy, an additional backup hydraulic line.
We have 4 hydraulic systems, so if one fails, it's not a big deal.
In Hyderabad, the AN-225's hydraulics have been fixed, but local air traffic control can do nothing to speed up its departure.
We will be late with departure because of all of this. Maybe I will have problems with my management because our policy is just keep the schedule. It's my fault. I should have known. It.
Dimitro and his crew have no choice but to wait for a takeoff slot. But what they're unaware of now is that at their next stop off in Kuala Lumpur, they will encounter every crew's nightmare.
We have to remove the part.
Engine trouble. May 13th, 2016. The enormous Antonov AN-225 is on a $3 million contract to deliver this 144-ton generator to Perth, Australia. Time is critical, but the plane has been held up in Hyderabad.
We will be late with departure because of all of this. It's my fault. I should have known. It.
After a long wait, Dimitro gets a green light to fly on to the next fuel stop in Kuala Lumpur. When the AN-225, aka Maria, touches down in the Malaysian capital, engineers unfortunately discover a serious problem with one of its engines.
We have to remove the part, or it'll overheat.
The mission is in trouble. This could be a disaster. The Antonov won't be allowed to fly unless all its engines are working.
We can't connect it.
But exactly what does it take to get a plane this heavy to move fast enough down the runway to get off the ground?
An aircraft that weighs 705 tons at takeoff requires an enormous amount of thrust to accelerate it.
Antonov designers knew a regular set of engines would be inadequate. and they didn't have the money to invent a new engine. So they looked to the turbofan jets on an earlier cargo plane called the Ruslan.
The first engines were installed on Ruslan, and the same engines were installed to Maria. It was the first time in the Soviet Union that such an engine was developed, an engine of such size and dimensions and such capacity. The D-18T engine's thrust on takeoff is 24 tons.
These D-18T engines are high bypass turbofan jets, designed to produce more thrust than a standard jet.
Turbofan engines produce thrust through basically a combination of two mechanisms. So first of all, it is a gas turbine engine combined with essentially a fan, turbofan.
So there are two ways you can increase the thrust. You can increase the speed of the air that goes through your engine, or you can put more air through that engine.
These put more air through the engine. As with a standard jet, there's a combustion chamber that delivers thrust by expelling exhaust out over the turbine at the rear.
That turbine also drives a fan, which is housed at the very front of the engine.
This is the clever part, the turbofan. As the turbine spins, it spins the huge fan at the front of the engine. This sucks in a massive volume of air and sends some outside the combustion chamber to these bypass channels. This air is then accelerated out the back. Incredibly, 80% of the engine's thrust is produced by this bypass.
By having that big area of the fan putting out the air, even if it's at a lower velocity, it's such a big area, it's still moving a lot of mass, and it's more efficient than just using a pure jet engine.
These engines are really big and very powerful. They have around 70,000 horsepower. Now that's equivalent to over 400 average cars each.
The Ruslan has 4 of these engines, but for the AN-225, the Maria, 4 would fail to produce sufficient thrust.
They made an extra center section of the wing so they could fit more engines. So instead of 4, there are 6. That means their total thrust on takeoff is over 100 tons. Can you imagine? That's the capacity of these 6 engines.
Dmytro and his crew are still stuck in Kuala Lumpur, waiting for one of his 6 engines to be fixed. They need to take off soon, or they stand no chance of arriving in Perth on time. Both money and reputation are at stake. For 30 years, the AN-225 has had a devoted cult following. While crowds start to assemble in Perth for the rare chance to witness the AN-225 landing in Australia, the plane is still stuck on the tarmac in Kuala Lumpur. They've had engine trouble. But after a lengthy hiatus, it's fixed, and Dmytro gets ready to take off on the last leg of the journey.
Виталий, нет. Кеттеринг. Через 15 минут по полету.
But there's another hitch.
Just waiting. No flight plan in the system in Kuala Lumpur Tower. We're waiting. Vitaly calling to office about this.
It's not our fault. This flight plan was filed 5 hours ago. It's the fault of Malaysian air traffic controllers.
Eventually, the crew negotiate a new flight plan and clearance to take off at last. Another 2,600 miles, and the AN-225 will reach its final destination in Perth. Landing this sky monster, loaded up with 144 tons of cargo, is the most critical part of the mission. How on earth can the plane land with all that weight without smashing into pieces?
Typically, the landing part of any flight, and certainly an aircraft, for an aircraft as large as the Antonov, landing is going to be the most dangerous part.
It's going to need a significant amount of runway in order to come to a stop, up to 11,000 foot.
But touching down safely anywhere for this super heavy behemoth of the skies is a procedure fraught with risk.
If you ever look at a commercial aircraft, you know, the wings deploy down and it basically makes this huge sail in order to redirect the air in a different direction and catch that air and slow the plane down.
Fine control of the approach speed is critical. If it's not perfect, the landing must be aborted and reattempted. It's known as a go-around and can add thousands to the bill.
We know exactly our performance, and I can calculate what exactly landing distance need for this weight.
After flying more than 8,000 miles, the AN-225 has to make just one more landing at its final destination, Perth, Australia. Its colossal weight presents a particular engineering nightmare at the moment of touchdown. A regular undercarriage could buckle on impact.
If we will land all landing gear in one time, it's a little bit bump. It's not good for a plane.
And that's all about distributing the weight of the plane over many tires instead of like one tire that could easily blow out.
Dimitro knows that to bring the plane down safely, there's little room for error. The AN-225 approaches the final destination of its long journey, Perth, Australia. It's the plane's first visit here, and as with any landing, the moment of touchdown is critical.
The Antonov undercarriage is amazing because of its sheer scale. It's made up of 32 wheels.
The unique undercarriage arrangement is normally hidden during flight inside the massive fuselage. 8 rows of struts hold the incredible total of 32 wheels to spread the force of the impact. But the real secret for softening the landing is the state-of-the-art suspension system. Each wheel is mounted on what's called an oleo strut, a high-performance oil and gas combination shock absorber.
That is like a piston inside of a tube. And inside the tube is a combination of nitrogen gas and oil, which together allows some sort of elastic effect, but also a viscous damping effect when combined.
Landing also puts huge stress on the tires. The 225s experience so much friction, they heat up to 250 degrees Fahrenheit. What's to stop them from exploding?
So these wheels are made of rubber reinforced with a steel mesh, which makes them really, really strong. And even if one of them were to fail, they're filled with nitrogen, so it wouldn't be a catastrophic explosion if it did fail.
But they do lose a lot of rubber every time they hit the tarmac.
These tires need to be replaced every 90 landings, and every time you do that, it costs $1,000 per tire.
News of the giant Antonov's imminent arrival in Perth has now brought traffic jams and a 30,000-strong crowd to the airport.
It hadn't been there before. It caused such a furore. People knew Murillo was going to arrive, so they were waiting there for a few days. There were thousands of people.
To the delight of the spectators, Dimitro pulls off a perfect landing.
Alpha Delta Bravo 3610, welcome to Perth.
Massive. It's well worth coming down.
That's pretty impressive, yeah? It's good fun to see something a bit different.
To see it in real life is just mind-blowing. You have to be here to see it. It was really, really exciting. It's probably about the best thing and most awesome thing I've ever seen.
After landing, we see person staying around airport near the fence, and all with photo. And in this moment, we are all crew feeling very proud. All person proud to be a part of the team of this plane. It's amazing feeling.
The huge generator can now be offloaded just a day late. And a group of Ukrainian expats celebrate with the exhausted crew. Whatever the future holds, the Antonov 225 is a unique plane that soared into the air from behind the Iron Curtain and shocked the world with its huge size and unrivaled capabilities.